To understand outside-in inspection and cleaning, we're going to uptrain, not necessarily retrain, but uptrain to a higher standard. If the test port is dirty, debris can transfer to the connector ferrule and then to the end face. The connector assembly is a three-dimensional structure. Now that may seem obvious to you, but existing standards only consider the end face only as a horizontal surface. The intent of the session is to implement best practice. Working from the outside in, it only makes sense. The debris can cross-contaminate all along the way. And before you think that I'm promoting that we clean all of these surfaces every time, that is not the case. We clean the primary surface as defined by IEC. That's the core. I believe that the total horizontal end face should be expanded to be a zone 4. Clean the total horizontal end face. Do it properly. If that doesn't work, then you move to the other sectors of the connector. It's not clear to me why IEC doesn't recognize other sectors of the connector than their definition of zone A, B, C, and D. There are other sectors, test points, alignment sleeves. I recharacterize the vertical ferrule to include the total horizontal as zone 4, and then zone 5, that's the vertical surface and other sectors of the connector. All of these are important to critical cleaning. The test port in the upper left could also be an alignment sleeve. Looks clean. Let's enlarge it. Notice there's debris on the right-hand side of the inside diameter. Yes, that debris can cross-contaminate. Here's a probe tool. Notice that the tape, actually that's a thread, that's 0.9 millimeters, and housed in a plastic surround. Notice how the housing fits, but the thread doesn't fit. That won't clean the entire end face. This is a stick. The stick fits, but the stick is a harder surface, more difficult for the stick to capture debris. More acceptable would be a hicher brush. That brush would whisk away the debris on the test port or on the alignment sleeve. Bottom right, that's a clean room grade swab tool. That will simultaneously clean the alignment sleeve and the backplane connector. This MT port, or could be an MT alignment sleeve, is contaminated. So always take a look, always observe the inside diameter of these connector surfaces. Notice this is a typical MT thread. It doesn't match the inside diameter of the test port or the alignment sleeve. This is a clean room puff. Notice how it completely fills the inside diameter of the test port alignment sleeve. In recent times, I've really become hard against dry cleaning. Lightly moisten all of these tools. The moisture attracts, the small amount of moisture attracts the debris and captures it in the inside of the cleaning medium. Condition of the adapter housing. Actually, the condition of the work area that you're in is a first alert of potential end face contamination. If the shell is dusty, the end face is dusty. If the work area is dusty, maybe the shell is dusty. It's a first alert. These images are pretty remarkable. Upper left, that end face actually probably will pass the IEC standard for cleanliness, even though the adapter, the alignment sleeve, is soiled. Speaking of alignment sleeves, take a look at these. These are badly contaminated, and there's no practical way to see them in the field. Here are your adapter shells. They are also contaminated. So here's a comparison, a probe tool thread and a swab tool. Notice the thread doesn't have the inside diameter, the outside diameter to clean the inside diameter. The swab tool touches the alignment sleeve, cleans it simultaneously with the end face. So they're two cleaning surfaces, one vertical and one horizontal. These are the advantages of the different tools. Optic deployments have come a long, long way over the last 25 years. Diverse environments, debris of different types, almost everywhere. So some in the industry claim that one deployment is more mission critical than the other. I believe there's a need for one open architecture procedure that crosses over so that the contractor who's working traffic control in the morning and fiber to the home in the afternoon and doing some sort of a data center maintenance at night, the process is the same. The transmission fiber has no clue where it's deployed. What matters is the condition of the end face, the condition of the transmission fiber at the time of test and transmission. Sure, you've seen this before. This is the IEC definition of an end face. It's broken into zones, 4 zones, A, B, C, and D. What's interesting is, and for me troublesome, is that notice that the largest zone, zone D, extends only to about 250 microns. Now, there are new proposals, and one of them, I believe, is to extend that, but then the other one is to reduce this from 4 zones to 2 zones, a lower standard. There are some of us in the community who believe that these should be a wider standard. Consider the connector in 3 dimensions, more rather than less. It's a fair question, but I've spent my whole career since 1968 in different facets, industrial facets of cleaning, some cleaning and some precision cleaning. In 1999, 2000, I was asked, how do you clean a fiber optic connection? And here we are today. This is the latest work, and it amalgamates all that I've learned from you in the field, you on standards committees, you my colleagues, pro and con. We start with the test port, connector shell, alignment sleeve, and end face. I guess we're going to debate the total horizontal surface, but the fact of the matter is that these are 3-dimensional structures, and the standards need to reflect more. Okay, so let's get down to it. How do we do this? How did we get to where we are now? The history of precision cleaning, well, it wasn't precision cleaning in 99, 2000 to 2003. It was just cleaning. There were 2 cleaning recommendations. One was dry cleaning, and the other one was wet cleaning. So where we are now is there are 2 cleaning processes. One is dry cleaning, and the other one is wet to dry cleaning. What's wrong with dry cleaning? This is work that is done, well, not only that I did, but Cisco did it. Dr. Tatiana Berdanskaya also did the work on on static. So dry cleaning is not effective on a wide range of debris. This is what the Cisco series showed us. And this is what I researched and published in the study of precision cleaning fiber optic connections. Let's talk about Dr. Burdenskaya's work. A small amount of static, it's called a tribocharge, moving from 31 to 38 kilovolts, created this much static in an early lab test at Chemtronics in 2007. What we also showed was, and this is in the bottom right, dry cleaning a complex debris only moves debris across the end face. It doesn't remove it. So my recommendation is to abandon dry cleaning. Let's uptrain to a higher standard. But is that higher standard wet to dry cleaning? Let's take a look. So if there's something wrong with wet to dry cleaning, you're probably wondering, how did we end up with the phrase wet to dry cleaning? It's because this is a phrase, quite literally, that was taken out of 2003-2004 training. The process began to eliminate wet cleaning and introduce wet to dry cleaning. What you're going to see in this video is that the problem with wet to dry cleaning is that how to moisten the end face is not defined. In the video, the technician is taking an end face and drawing it through a pre-saturated isopropyl alcohol wiper. That alcohol wiper could also be saturated with something out of a pump bottle. Then what you see is that how to dry it is not defined. Even with repeated and conscientious serious drying, flooding continues from what I term zone 5. That's the vertical ferrule all the way at the end of the horizontal ferrule, and it's not seen. So the problem here is that even though, as you will see, with the fourth or fifth effort, even though this end face is dried, it will pass auto detect because the 250, 300 micron IEC surface is clean and dry, even though there is fluid coming from zone 5. Wow, lots of stuff. So how do we end up with wet to dry cleaning? It was extracted from a training video. Wet to dry cleaning needs to be clearly defined. How to moisten the end face, how to dry the end face, and how to do this in a first-time procedure. It's realistic. It can be done. So when I say vendor neutral and open architecture, I really mean it. What I'm showing you here is how to moisten all of these tools and how to actually use them. You always want to use a small amount of whatever your choice of fiber optic cleaner is. Don't use IPA. It simply isn't effective. You want to moisten the cleaning platform, moisten the swab tip, moisten the reel cleaner. This is best practice. If you need more information, take a look, please. The textbooks on the bottom are available on Amazon. The comparison study of precision cleaning methods, that's 2015. It is 150 pages. It is a little bit dry, but it is a proof positive method and procedure that goes through using these tools. The image to the right is really fascinating. This is a 2.5 millimeter probe that is cleaning a 2.5 millimeter end face. The black arrows point to the actual cleaning surface. That debris is a fingerprint. These unique digital images, and there are more than 5,000 of them, are taken on the RMS-1 Mark II. This is digital photography, and it's a different way to view the fiber optic connector surfaces. It's important to consider all potential sources of cross-contamination. A lot of conclusions, but I think the important takeaways are that it's time to uptrain and understand the concept of outside-in cleaning. If the test port is contaminated, ultimately that debris can transfer to the interface. Surely, this does not happen all of the time. However, when cleaning the IEC surfaces, don't eliminate reflection or insertion loss. Clean the other sections before you replace the jumper or terminate or return the electronics. My recommendation is to assure the total horizontal surface is pristine, beyond IEC standards. So, would you help me spread the word? I hope that after reviewing this presentation, you see that there are a lot of conclusions and a lot of it's new information. Below is my Patreon account. Any support you can offer will be gratefully appreciated. It helps me fund shows and different events. You understand. So be well. I look forward to your comments, look forward to your support, but I also look forward to your challenges. Let's spread the word. Let's start the conversation to advance standards to a higher level.